Okay, so here's the recording for 5-7, solving quadratic inequalities. I do apologize that I forgot to do this earlier, but it's here and y'all can go back and review this anytime. Again, our goal with this lesson is to be able to solve quadratic inequalities using different methods. Now, sometimes those can be, and we'll first do some graphing quadratic inequalities, but again, we'll show how we can do that with a couple of different methods. So the first thing we want to do is we want to say make sure you have this right here. We're going to look at the graphing quadratic inequalities, and make sure you have this little chart here that could be put into your like note card about whether or not when you decide if it's a broken parabola, solid parabola, shade above and shade below. So our first example is going to be y is less than negative 2x squared minus 4x plus 6. Now, the way I've shown this, again, I like to do this with the calculator, so you have to go back through those steps. I don't have a way to show the calculator here. But what I would do is that I would graph this on the calculator, just the negative 2x squared minus 4x plus 6 as like F1 or F2, and then from there, you might want to do a menu trace, and then with the menu trace you could say find the points, the zeros and the vertex. That should allow you to get 3 points that you could graph on your paper. And then from there, once you've got those 3 points, like in this example, you go to the calculator, you graph those 3 points, and you get these 3 points. 1, 0, 0, 1, or 1, negative 8, and negative 3, 0. Okay. From there, you could graph those 3 points. So you can see here how I'm graphing those 3 points. And then you would decide, okay, based on those 3 points, what kind of parabola am I making? Broken or solid parabola? Well, according to this is a broken parabola. So that's what I've got drawn here. Then from there, you need to decide, is it above or below? Well, this is less than. That's shade below. Now, what is shade below? Well, that's why I usually like to make little dots that are above and below the vertex. And I can see the lower red dot is below the vertex. Well, that would make me think less than, so then that's where I would shade. So that's how you would decide for less than and greater than, and which way you would shade. Another example, I know this one gets a little bit brighter. Y is greater than or equal to negative 2, parentheses x plus 3 squared plus 1. Okay, using the calculator again, I could find the vertex and the zeros, and I end up with negative 2.3 comma 0, negative 3 comma 1, and negative 3.7 comma 0. Okay, graph those 3 points. This one is a solid parabola, so I'll make it solid. And then again, I want to do greater or less, make my 2 little dots, and I can see the upper blue dot is greater, so then that would shade on the outside. Enough to tell that I shaded on the outside. If you have any questions, feel free to ask me through Edmodo. Okay, then we get to solving quadratic inequalities. And for solving quadratic inequalities, we want to say we're going to first do this algebraically. Alright, so solving quadratic inequalities, we're going to do this algebraically first. And now, I want to make note here, you can solve this any which way algebraically. The focus that you're going to see on these examples is with factoring, but you can solve it algebraically any method. And I might put up something else later showing you some of those other methods. Like you could use a quadratic formula if you wanted to. Type it in the calculator, press enter, and get an answer. And that might be quicker. And then use those as your critical values. Okay, so to solve this by factoring, we need to get the 6 to the other side. So we move the 6 over, and then we've got minus minus. 1 minus 6 is negative 5. And that actually should say equals 0. Alright, so with minus minus, I would put up my parentheses and say minus minus is a plus minus. So we would have xx, and then plus minus. two numbers that multiply to give me 5 are 1 and 5, and they subtract to give me a 4. And now to get a negative 4, I want 1 minus 5. So that's the way I've got it written. Set it equal to, each one of those equal to 0. Separately, all that really does is change the sign of them, so then I would have x is equal to negative 1 and x is equal to positive 5. Those are critical values. Okay, ignore that, what's being written there. There we go. The critical values means that I'm going to test, because I'm not done. I've solved, but I need to find out like what values for x. I know depending on the negative 1 and 5, I can get values of x that will help me decide if I put them in there into the original question, they would give me answers greater than 6. So I draw a number line. I'm going to graph my negative 1 and 5 critical values, and because it was in greater than, I'm going to have open dots, and I need to test a point. And like I said, the book will want you to test 3 points: left, middle, and right. If you just test the middle, if it works in the middle, then you shade in the middle. If it doesn't work in the middle, you could shade outside. So I'll test 0 in the middle, put it back into the original equation, the x squared minus 4x plus 1 greater than 6. When I put 0 in there, I get 1 greater than 6, which is not true. So in the middle doesn't work, which means I need to shade outside. Thus, x is less than negative 1 or greater than 5. And you're done. Okay, and that's how you could look at it and read it. Okay, moving to another example. And then if I solve that one, I get x squared minus x plus or minus 2 is equal to 0. And I would go from there. I would go from there to say minus minus is a plus, minus again. Fact numbers that multiply to give me 2 would be 1 and 2. So I'd have x plus 1, x minus 2. Set that equal to 0. I get negative 1 comma 2 or 2. Put that on the number line. And then again, I test. 0 falls in between. Any number would work as long as it's in between. Okay, so I'm testing 0 because that's pretty easy. 0 squared minus gives me 5 less than 7, which is true. Since 5 is less than 7, I'm going to keep going with that and say shade in between. Thus, since I'm shading in between, my x is in between, and that's how I would write it. Negative 1 is less than x, which is less than 2. Okay, so that's solving algebraically. Now let's look at solving with graphs and tables. Solving with graphs and tables, or I'm sorry, yeah, and that would be using the calculator. Okay, and again, I won't be able to show you with the calculator, but I can kind of give you an idea what will happen. Okay, so solving with graphs and tables, I got this problem here: x squared minus 6x plus 8 less than or equal to 3. Now on the calculator, I'm going to type in the x squared minus 6x plus 8 is equal to is f1, and the 3 is f2. Okay, so if I graph this on here and I get the table from a calculator, and any calculator could technically do this. So I want a table. I would end up with like x, f1, f2, and I would look for, if you notice on f2, it's all 3's. Okay, so I would look for something that would give me 3's along f1. 3 and 3. Okay, and I see that happens at 1 and at 5. Okay, all the numbers in between don't matter, but like, okay, let's say here I have 3 and negative 1, and out here I have 0 and 8. Okay, so the question here is you see here, this is less than or equal to. Okay, where is the answers in F1 less than the 3 that is in F2? And you can see this happens in between, because these right here are my critical values. That's going to be part of my answers. And either my answers are going to be like this, x is in between, or x is going to be less than the upper, the lower value, but it's the upper one on the table, or x is greater than equal to whatever number. Now, you can see here, we want to know when it's less than. And if you look here, this is less than right here, in between. So, between the critical values is where these statements, any number that you choose between 1 and 5 would give you answers that are less than or equal to 3. And that's what the table is trying to show you. And that's why I chose this answer. You look at another example, and this one is going to be 3x squared minus 3x minus 1 less than or equal to, or greater than negative 1. Again, I would type this into the calculator, get my table. I am, again, not as concerned about the graph as much as I want to look at that table. And if you notice, again, on the table, you should have nothing but negative 1s, like going on the outside. Then I want to see where is it on the graph that it has negative 1s also. And here. And you should see that at 1 and 0. And at negative 1 and 2, you would end up with 5s. Okay, so this one I can't really see, look in between. But again, either it's going to be x is between two answers, or x is less than one number, or greater than the other number. So I look at my critical values, and those are my critical values, 0 and 1. So either it's going to be 0 and 1 here, or 0 and 1 here, like that. And actuality, that's greater than, so I don't need the line underneath. So let me erase that. Okay, so now the question becomes, is it in between, and I can't look in there, or outside that the answers are greater than negative 1? And if you look here, let's try that again. If you look here and here, that's where I can see that the answers are greater than negative 1. So then that means my answer has to be this one right here. X has to be less than 0 or greater than 1. That's 5-7, and basically, and if you have any questions, feel free to ask. Thank you very much.